Hi, today we will assemble my VGA board kit. That's my first product that I'm selling on Tindy. And there are instructions inside, but you can watch this video and follow it to assemble it if you purchased one. They are limited, 100 in count, and if you are lucky, you have one. Okay, so I will stop the time so you can challenge me. If you are faster than me soldering it, that will be cool. And I'm using like my soldering station here. I set it to around 380 degrees. That's on the high side. You will probably damage boards if you use or components if you use that temperature. But this one is only passive components and only through hole pads, so they won't lift, and we are quicker. So a little bit of cheating. I'm using a 2mm tip, so we have a lot of heat inside and can solder faster. So let's open it and take a look inside. What's inside here? So we have the bag with that way. These are the instructions. And that's like a little poster themed like my videos that I did lately for the VGA stuff. And you can see what should be included and the instructions how to solder it, and also the schematics, some resistor codes, and so you can use it even later. And this is the kit number 43, so I got even a stamp of 100, and you found probably this video over this link here. And let's start. Okay, let's check the components here first. We have the resistors, so you can try to identify them, but they are easily, even for me with my color blindness, they are easily to recognize, since there's the orange for the tree here, and here I can recognize these colors, but this one has here the gold for factor 0.1, but that doesn't matter. They are labeled here, so you can use them. So this is T, this is R, and this is 2R. Then we have the board itself. So this is the VGA board, and here is the VGA connector. It's just plugged on to protect the pins from bending during the shipping, so we can just remove it. So we have the board, the resistors, and some silica gel and some pin headers. Okay, so this is the back. Then we have 4 pin headers for the microcontroller. They come here. And then we have this one dodgy pin header, and that's used as a helper. I will show that later. So I will turn on the stopwatch and let's start the solder. Okay. So I will use this here. It's quite convenient with boards like these here, so I can clamp it in, and put the components on and rotate it if I need to focus it a little bit more. Okay. So I like to start with, let's take my, so I use lead-free solder, so this is a small handicap since it's harder to solder with, and I like to start with the 150 ohms R resistors. So you can see here on this side there are marks, so you can see every single rectangle here. This is a resistor and it's marked like R, 2R and T. Only 3 T resistors here. T for trimming, so this trims down the voltage to get the desired 0.7 volts signal at the end. Let's start with the row here down below. We have 3 resistors. I removed them from this strip and just put them in. Okay, like that. And I will bend the legs like that to prevent them from falling out when they are upside down. And now I will just put a little bit of solder on my tip to clean it up. So I have here this brass, and I keep a little bit of solder on the tip to get it easy transferred to the pad, and like that. It's a little bit harder with the camera since I can't watch it, and I have no fume extractor for the sake of the sound now, and I can rotate it right now to do the other side like that. Okay, so now I will use the clipper and clip one leg at a time to not stress on the pads and rip off some traces. Can't really see it, but something like that. So that's the first. Oh yeah, that one is a little bit standing up. So the guy that gets this board knows it is this one that was soldered on camera. Okay, the next 4. Whoops. Okay, I lost one, but I put in spare ones, so if you damaged one or lost one, doesn't really matter. You should have a few spare resistors of each type. Let's zoom in a bit so you can watch close up. So. I can't really see from far here, but it should be okay. There are some pads that are connected to the ground plane on the bottom of the board. So this is the bottom, and we have a huge ground plane, and the ones that are connected to the ground pad are a little bit harder to heat up, so you could get cold solder joints. And there is even a small picture on the instructions here that shows this. This one here is a cold solder joint, or yeah, that could look like that, and this is how it should look like. Okay, this is a little bit long here. Okay, so maybe while I'm soldering it, I can tell you what the board is actually doing if you didn't watch the series on the topic. And this is simply these are we are generating 3 signals for the VGA output, and VGA works with RGB signals, and the higher the voltage, the brighter the color component is. So we have red, green, blue, and from these 3 base colors all other colors are mixed. And R to R resistor ladder is a really simple way with passive components to generate from digital bits an analog voltage. This is a digital to analog converter. And since we are limited to 16 bits with the count of let's say for optimization, count of pins that are available on the microcontroller and memory, we are limited to 16 bits for the output, and there are 2 additional signals, the H-sync and the V-sync, that are controlling how the picture is transferred. So the screen waits for a vertical sync pulse and a horizontal sync pulse, and each vertical sync pulse a new frame starts. So in the cathode ray tube, it would start from the upper left corner, drawing the image from left to right. Oh, I just closed a hole that's is not soldered yet. Oh, yeah, that's a small difficulty that I will show you how to fix it. So I have already a small mistake here. I will show this. So I just closed a hole by accident. Okay, but let me finish explaining here. Yeah, the image is drawn from left to right, from top to bottom, and each pixel row we have the horizontal sync. So the syncs determine the resolution, so how many rows are drawn, and you could theoretically use an infinite or the horizontal resolution that you would like to. You can use lower resolution or higher resolutions on cathode ray tubes, but on TFTs there are a limited count of pixels. And yeah, so this is a little bit, where is the closed hole? Okay, so this is how this works. So we have only we have the 2 sync bits and 14-bit for the colors. So since this is the blue channel, since we have like 5 bits. No, how much is it? Well, yeah, 5 bits red, 5 bits green, and 4 bits blue, since blue has the lowest brightness, so it doesn't really show if you reduce the bits. Okay, let me show the problem that we have right now. So I just show it like that. Yeah. So we have this hole here, and that's closed. So there's no resistor in, and we can't put the resistor through. So this might be a difficulty, but I will show you how to fix that if you have this problem. yeah, we are done with the resistor value R. So with the 150 ohm, we're done. I lost one and have even 4 spare ones. And now I will continue with 2R, and I will fix the error that we have now here with this closed hole. So what I'm doing here, yeah, you have to be a little bit careful to not burn yourself. So I can still put the leg in a little bit here in this hole that's closed, but I can't put it through. And I will grab the resistor on the other side of the resistor itself, and I will try to push it a little bit while I heat up the pad that's closed. So I will melt the solder and try to move the resistor leg through. No, that's not the right hole here, like that. So this is a little bit tricky. I hope I can show it on camera. I will just move it a little bit around here, because that messes with my time now that I wanted to challenge you with. But yeah, so like that. I hope you could see it, how it moved through, and now it's easier. I can just use a little bit solder at the leg to move it through. Oh, I think no, it wasn't too far. And now I can put the complete resistor in, like that. Sorry, we'll just zoom out again. Now, like that. And it's even placed okay now. And yeah, I'll just leave it like that. Okay, so let's even start with this row with the 2R resistors. We'll zoom out a bit. Okay. If you're a complete beginner, the resistors don't have any specific direction. You can put them the way you like. And this short here isn't very bad since these are connected anyways, but you have to prevent shorts between when you see these 4 holes here. I hope you can see it. The hole that's a little bit further away, that should not be shorted with the 3 ones on the top. Okay, next row. Oh, that's also a hole that's closed here. Okay, I have to take care of this one here. How does this happen? Even twice here on camera. It's hot. Come on. We'll leave it like that. It's okay. it's a special one. No, I thought it was another closed hole. I will just shut up and speed this up a little bit. Okay, last row. It has something of meditation at the evening after you've done some hard work, thinking all day, and just soldering the resistors in. And it's even a little bit relaxing. Okay. Okay, now the last three resistors, the trim resistors here. So these are usually the signal after the resistor ladder has the value of 3.3 volts max, and we have to voltage divide it down to 0.7 volts. And I think the resistance is summed up here, and the signals is like I think it might be even 2R or something. And I did the calculations that you get around 0.7 volts if you set the brightness of the color channel to maximum. So it should be okay. If you're worried about the current that is flowing between the last channel and ground, here there is a misconception about the ESP32 that it only supports 12 milliamps on the pins, but that isn't really true. You can even set the drive current of each pin, and the default one is like, I know, the maximum current is 40 milliamps, and default is something like 20 or something like that. Not sure, but the default is high enough. I checked it, and that's something that I even, this trim value is something that I even changed in the latest stage, and I even when I uploaded the last video, I even had planned to use R for as trim, so 150 ohms, but in the really bright colors it was oversaturated, and I checked with the specifications of the microcontroller and ordered some resistors to get it with the best possible quality to you. So I even realized that it's the best to if you're buying resistors like these in large amounts, it's even better to order them from locally from Germany or wherever you live, since the weight to value ratio is so bad. The shipping is too high for like 1000 resistors, but the value of you get 1000 resistors is like theoretically you can buy them for like $1 or $2 or whatever, or $5 max, but the shipping is like $10 or something. So now I will just put the connector on. This is on the side of the resistors. I have to be careful there. It's like that. It snaps in and holds itself in place. And that one is quick. I will fix it in place here with just soldering here these clamps. And that is even easier to solder than you would think. This is not connected to ground on this board, so it's really easy to solder. And now the pins. This one is ground, so this is harder to solder than the other stuff. Doesn't stick. No. Okay. Here's another ground. Good enough. Now the pin headers, and this is the last part here. They are also on the side of the resistors. I will show complete board here, just like that. Okay, this is a little bit stiff. Like that. And now the problem is, if I would just start to turn it around and start to solder it, it just moves around, and you never get the distance right between the rows. I have so many pins here now. So I just included this female header that should be exactly as long as you need it to just keep them straight here. So you put this on, and it acts like a one component. You can even put your finger on while you tag it in place. So everything is straight and fine. And you just take a little bit of solder here. It's a little bit hard to solder pins since they take a little bit more to heat up. But if you take a blob of solder and just take it in place at some pins so they don't fall out anymore. Where's the solder? Yeah, I would need another hand here. And that one doesn't like to be soldered, so I take another pin. No. Okay, show effect here. If you know a better method, maybe take it down from this stand here. Oops, no bridging here. Yeah, it's held in place already. Okay, so now I have it tagged in place and can take a closer look and start soldering the pins. So let's speed this up a little bit. Okay, this seems to be a cold solder joint. Heat it up. Now it should be fine. Okay, and now I just remove the helper here, and you can just keep it or throw it away or whatever. So, and that is the finished board. I will just stop the time. Oh, 36 minutes. That's not my best time. I had like 20 minutes once, but yeah, that's the only time that I can prove. And if you are better, just yeah, post your time in the comments or whatever, or tweet it or send it on Instagram with your soldering job, and I will like to see it. So tag it with @bitloony or whatever, or hashtag ESP32lib. So this one here, where is it? This hashtag here. And I will just put it now in my ultrasonic cleaner here for a few minutes to get rid of all the gunk here, and then we can test it. Oh yes, much better. No flux residue anymore. Okay. Let's get it dry. If you're asking, I'm using 100% isopropanol, so it doesn't create any shorts. The last thing that is important is how to put the microcontroller on. So I have two types here. So if you ordered from me, you have got this one, and this is also the one that I linked everywhere. So you solder the female pin headers on top here, like this. And I did this this way around. This is the typical way around to solder them, but I also did this to get the smallest footprint or the smallest thickness on these here. So and you can always, to get the direction right, you can see this here where the board is missing. This is the place for the antenna. So I put this like that on here, and yeah, we have no ground plane that is covering the antenna here, and it should be the same height now, and it's as flat as possible, since all the components are on the other side, and they are also a little bit more protected. And yeah, that's like this. And also take it off again. Also with this one, if you got the TTGO or the TTG0, I'm not sure. If you got this ones here, that they have also a switch here to turn it off, on, and a battery connector. The same around. You can see the antennas on this side and the components, or the IC components, and you put this way around, and yeah, like that. Now let's head over to my TFT screen and test if it works. I plugged in power here, and now let's test it. And yeah, it's a colorful graphics. I will turn off the lights so you can appreciate it more, like that. And yeah, that works great. And this is also the test sketch that you should see if you ordered, if you were happy to get a microcontroller from me. I had only like 12 on stock. Yeah, sorry about that if you had to get yours from China or wherever. Yeah, but yeah, I wasn't able to get all these upfront 100 pieces. That would be like $500. And I didn't know if anybody would even buy this. So, and yeah, that's all from the hardware. And what I will show you now is how to set up the software if you don't have it already. The VGA board works with all kinds of development environments, but the Arduino IDE is the simplest one to start with. If you haven't ever worked with it, you can download it for free on this page here. You can find the links in the description. After you downloaded and started it, you have to add the support for the ESP32 microcontroller. And this for you need to enter in the preferences this link that is also found in the description, and add the support in the boards manager. Simply type ESP32, then it will show up, and just click install. When this is done, I recommend you to use my library that I prepared to use the VGA stuff. So you have just to go to manage libraries and type in ESP32 lib, and that will show up. Just install the latest version. Now you have to select the board first. So we pick the ESP32. We can choose the dev module as default, or I'm using the mini kit here. And then we can simply use the examples that's installed with my library. And then you can simply use something like VGA 3D engine, and it would load the example here that's commented. You simply have to program and upload it after selecting the right port here. So the right port will show up when I plug it in. Simply have to close the menu and reopen it after connecting the microcontroller, and this is the new port that showed up, and I will just select this and upload it. And that's all. Now you can start hacking in the code and develop your own solutions using a VGA display. Thanks for supporting my channel, and yeah, see you next time. Bye.